Students, in this video we are going to discuss the binomial theorem and its use in expanding any binomial with a higher index. So before entering into binomial theorem, let us see the expansion of binomials of small indexes. For example, a plus b whole power 1 is a plus b. A plus b the whole square, which we can write a square plus 2ab plus b square. A plus b the whole cube, a cube plus 3 a square b plus 3 ab square plus b cube. A plus b whole power 4. What can be its expansion? You look at the first three expansions. Always the first term is the first term in the parenthesis with the index. So a, here we have a and the index is 1, so we have a power 1. And the last term is the second term in the parenthesis with index. See, in every expansion, first term is a square and the last term is b square in a plus b the whole square. Similarly, in a plus b the whole cube, the first term is a cube and the last term is b cube. So what about the first and the last terms in a plus b whole power 4? So we can say that a power 4 is the first term and b power 4 is the last term. Next, let us see the number of terms in each expansion. What is the index of a plus b here? 1. And how many terms we have? A and b, 2 terms. What is the index in a plus b the whole square? 2. So here the number of terms a square, 2ab, b square, 3. The index in a plus b the whole cube is 3. And the number of terms we have 1 a cube, 2 3a square b, 3 3ab square and 4 b cube, 4. So we can say that the number of terms in each expansion is 1 greater than or 1 more than index. So from this what we can say is the number of terms in a plus b whole power 4 should be 5. Okay. Now I am writing the first term a power 4. What about the next term? You see the previous two examples. First term is a cube. In the second term, the a power is reduced by 1. So it is a square. So here the power of a should be reduced by 1. So it should be a cube. And b term is introduced. That is the second term in this parenthesis. So here also we introduce b term and its power is 1. The sum of total power should be the index 3 plus 1, 4. And in the next term the power of a is again reduced by 1 and the power of the second term in the parenthesis is increased by 1. So same we should do here. Plus power of a cube is reduced by 1, so a square. Power of b is increased by 1, b square. And then power of a should be reduced by 1, so we will have a. And b will be increased by 1, 3. Last, power of a will reduced by 1. 1 minus 1, 0. Anything power 0, 1. And power of b will be increased by 1, b power 4. So I mean this is a power 0 into b power 4, where a power 0 is 1 and 1 into b power 4, b power 4. So I have written 5 terms. 1, 2, 3, 4, 5. But I did not write the coefficients of each term. We can see that in all the expansions, the first and the last term have the coefficient 1. How to find out or how to write the coefficient of the terms in between the first and last terms. For this we are using a triangle called Pascal's triangle. The construction of Pascal's triangle is very simple. See, first you write 1, and this is for a plus b whole power 0, which has only one term because the index is 0, so 0 plus 1, 1 term. What is that? 1, because anything power 0 is 1. Then I am writing 1, 1, which corresponds to the coefficient of first and last term. So this is for two terms expansion, or an expansion having two terms like a plus b. Coefficient of a is 1, coefficient of b is 1. Next, 1, coefficient of first term. Then for the second term I am adding these two numbers, 1 and 1, 1 plus 1, 2. Then I am writing 1 for the last term, this one. Again I am writing 1, which is the coefficient of first term. Then I am adding the numbers, 1 plus 2, 3, 2 plus 1, 3. After 1 I don't have any number, so I write as such. Next, 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, 1. So this is the expansion, these are the coefficients for the terms in the a plus b whole power 4 expansion. So 1 is the coefficient of a power 4, and this 4 is the coefficient of 4a cube b, and this 6 is coefficient of 6a square b square, and this 4 is again coefficient of 4ab cube, and this 1 is the coefficient of b power 4. Can we write the expansion for a plus b whole power 5? Before that we shall write the coefficients. 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, 1. So what can be the expansion for a plus b whole power 5? First term is a power 5. Second term, the power of a is reduced by 1. So a power 4. And the reduced power is given for the next term, that is b power 1. Then a cube b square. Power of a power 4 is reduced by 1 and power of b is increased by 1. Then a square b cube, a b power 4, a power 0 b power 5. A power 0 is 1, so straight away I can write b power 5. And what are the coefficients for the terms between a power 5 and b power 5? This is 1, 5, 10, 10, 5, 1. So we can use this Pascal's triangle to find the coefficient of the terms in between a power 5 and b power 5 for the expansion a plus b whole power 5. Why we say this is a binomial? Because in the parenthesis we have two terms, bi means 2. So two terms are expanded based on the index, so we call it binomial expansion. So up to a plus b whole power 5 or a plus b whole power 6 we can write, but when the index is very high, for example a plus b whole power 20, so it will have 21 terms, no doubt. But think about the Pascal triangle for the coefficients of terms in between a power 20 and b power 20. It will be very large in size and it will be time consuming to deduce the coefficients of these terms. So in such case what we can do is we can use a theorem called Binomial Theorem to deduce the coefficients of all the terms. This theorem is useful not only for expanding any binomial term, it is also useful to find out the coefficient of specific term in an expansion. So these things we shall discuss, and here we are going to apply the binomial expansion for positive integers. We can see that for based on the index how the coefficients are given. If index is 0, in the Pascal triangle we have the number 1, which can be written as 0C0 combination. If the index is 1, a plus b whole power 1, this can be written as 1 1. The Pascal triangle is 1 1. The base of the Pascal triangle is 1 1, which is 1C0 and 1C1. This 1 is the index. When the index is 2, such as a plus b the whole square, 1 2 1. This is the base of Pascal's triangle, and this can be written as 2C0, 2C1, 2C2. Similarly, when index is 3, the base of Pascal triangle is 1 3 3 1. This 1 is nothing but 3C0, 3 is 3C1, and this 3 is 3C2, and this is 3C3. For index 4, 1 4 6 4 1. What is this 1? 4C0. This 4 is 4C1. 6 is 4C2. This 4 is again 4C3, and finally 1 is 4C4. When index is 5, 1 5 10 10 5 1. This 1 can be written as 5C0. This 5 is 5C1, 10 is 5C2, again 5C3, 5C4, 5C5. So like this we can expand the coefficients of the terms in between a power n and b power n for any value of n for the binomial expansion a plus b whole power n. So based on this observation, we can give an expansion for a plus b whole power n where n is a positive integer, and this expansion is called binomial theorem. So for any positive integer n, a plus b whole power n is given as a power n, and its coefficient is nc0, plus next coefficient is nc1, a power n minus 1. The power of the first term is reduced in the successive terms by 1, and the power of second term is increased by 1 in the successive terms. So b power 1 plus nc2, a power n minus 2 b square, plus nc3, a power n minus 3 b cube, plus etc. Any term in between, say r plus 1th term, ncr, a power n minus r b power r, plus etc. Last term ncn, a power 0 b power n, and the a power 0 is 1, so I can write this as a plus b whole power n is nc0 a power n, nc1 a power n minus 1 b, plus nc2 a power n minus 2 b square plus nc3 a power n minus 3 b cube plus etc. You see here, when the coefficient is given as nc0, this is coefficient of first term. The quotient of second term is nc2. The quotient of third term is nc2. So quotient of second term is nc1. The quotient of fourth term is nc3. So if there is a term ncr a power n minus r into b power r, what is this ncr? Coefficient of r plus 1th term. So this is coefficient of r plus 1th term plus etc. The last term will be ncn b power n, and this is the binomial expansion for a plus b whole power n. Dear viewers, இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்துச்சுன்னா லைக் பண்ணுங்கள், உங்கள் ஃப்ரெண்ட்ஸுக்கும் ஷேர் பண்ணுங்கள், மறக்காமல் சப்ஸ்கிரைப் பண்ணுங்கள். தேங்க்யூ.